All right, so we'll introduce ourselves first. We're both a bit bewildered because we thought we were having a moderator with us, but we're not. So Chelsea and myself are going to give you an update on how we as engine manufacturers are evolving engine health monitoring and the benefits it'll give to you as either operators or management companies. So do you want me to start or do you want to?
Either first? Sure. Chelsea Rodstrom Allen. I'm with GE Aerospace, based in Cincinnati. I'm a sales director working in business aviation, covering the APAC region.
Okay. Mark Webster. I'm with Rolls-Royce, covering business aviation from India down to New Zealand. Like Chelsea, I do sales, but I also do customer account management as well, which can be technical, commercial, whatever. So I've got a presentation, and we've been talking about it, and basically we're probably going to say the same thing, but we'll start off and we'll take it from there. So we'll use my questions and we'll go through one. So the first one that was asked was, how was AI, EHM monitoring evolved over the last 10 years? So do you want to take that first and then I'll follow up? Or?
Sure. So I think, like Mark would say, over the last 10 years, things have really evolved from a more primitive approach where pilots are, writing down manually flight data to real-time in-air transmission of that data directly back to the OEMs.
Yeah. So as we said, we're going to probably capture some of the same stuff now. So traditionally how it happened, well, before engine health monitoring, it was the pilot writing down a snag, okay? And it was a reactive, yeah? You'd seen an event and it was a reactive event. Then we went on to snapshot data. So the aircraft was capable of taking a snapshot of certain parameters at takeoff and then again in cruise. That's all very good, but the problem is, it's only a snapshot, right? It's a 1 second, 5 second snapshot, twice in a flight, and the data was downloaded manually and submitted once a month. So again, very reactive. What we did then is we took it a step further and went to continuous engine health monitoring data. So on certain platforms, depending on the avionics, the aircraft is capable of capturing the parameters throughout the flight. And as you can see, the top picture above me is, each point there is one flight. Okay, so it's very difficult to see what's actually going off. Whereas the continuous data below, they are all the snapshots from one flight. So obviously you can see there's a lot more going off. It's more, it can be more proactive because you can see trends starting to happen before they actually occur. So this is, so I say we went to the continuous data, and this is just showing you an event that we had. So we've got this continuous data here, and on day one, we received the EHM data from the aircraft when it was on the ground, and we could see that there was a problem. We contacted the customer, we contacted our operational service desk, we had mechanics there, and we found out that the engine had HPT stage 1 blade missing. Okay? It had operated fine, we'd just seen a change in the EHM data, so showing you it's a very robust engine. We got the first photo taken when the guys boroscoped it. It allowed us to release the lease engine, and we did everything and got the customer back into service. And that just shows you, with accurate health monitoring data that's coming through all the time and not just being submitted once a month or something, you can really do something and act on it. So within a day, or within 8 hours of getting that data, we'd already rejected the engine.
Yeah, surely there's earlier detection and better proactive management of engine issues.
Yeah. And moving on from that, and Chelsea will be on board with this as well, the new generation of Pearl engines, what we've done with that is we've gone a step further. So if you look at that behind me, it's showing you that for the older products, the BR710s, it was just the standard EHM snapshot. Yeah. Then with the 725 on the 650, we had this continuous data. And now with the Pearl family of engines, we've gone this a lot further now, where we're getting, through the aircraft health management service that the airframers provide, we're getting continuous data that even goes down to LRU level. So if we want to, we can now track up to 10,000 parameters in the engine, which is an awful lot. Yeah? In fact, it's huge.
I liked the blade example. Just to kind of tag on to that, I'll kind of give you an example from GE Aerospace. We monitor over 45,000 engines globally. Obviously, business aviation is a much smaller sub-fleet. But pretty recently, we have had an engineering team that is specifically, devoted to looking at the analytics as they come in off of the aircraft. They're actually able to kind of look ahead to predict events that may happen. And one thing that they've been enormously successful at is detecting some fire detection issues. There have been issues with degrading fire loops on some of our passport engines, for example. And this engineering analytics team has successfully identified and proactively managed around 60% of those degrading fire loops. So it's really amazing what we're able to do with this real-time data that is constantly flowing in. And I think at a high level, the more data points we have, and this is probably something that's going to be recurring, but the more data points we have, the stronger the analytics and predictive maintenance capabilities we'll have.
Yeah, that's the same with us as well. The better the data, the more accurate the data, the more predictive we can be. The things that are in red against the Pearl are things that we're looking at, and we're actually looking at being able to do two-way configurations. So if we see something in EHM, we can send a signal to do something to the aircraft. Now, obviously, that's not going to happen when it's in flight. It'll wait till it's on the ground with engines off and through maintenance. But that's where we're looking to get to, is to be able to do things and get in there, intercept the message and do something before anything actually happens. So not available yet, but it's something that we're definitely working on, and that's where we're trying to get to. Well, I think we've just covered this, but
I think we did just cover this. There's maybe one or two more things that I could say. As OEMs, both of our companies are deeply embedded in the development, in the design, and then in the monitoring of these engines. And our tools are constantly evolving to meet the dynamic needs, right? That goes for single operators to operators with large fleets. And not only are we able to predict issues, but we're actually able to use the information we're getting to identify positive trends within the fleet, which ultimately could extend, the time on wing and reduce the downtime, so we can get you back up and flying more quickly based on a really good set of data that are coming in.
Yeah, so this will just run through really what you've said there. If you've got no engine health monitoring, it's a responsive thing all the time. Yeah, so the snapshot data was responsive. The continuous data, in a way, is responsive. But going to this data through the EHVMU on the Pearl series of engines, it's continuous. We can actually get in there and prevent issues before they happen. And what also you've got to realize, you may only have one aircraft, and you think we're just monitoring those two engines. Those two engines are actually being monitored against the performance model that we own. Okay, so we can see and predict against the model of an engine for that age in that region where it should actually be. So don't think, oh, well, I'm just comparing my one aircraft against itself. No, we're not. It's compared against the model and against the whole of the fleet. So, depending on how many engines of that type there is in service, that's how many engines that yours is being compared against to get a good baseline for your engine's performance. So what we were also asked is, how are we as OEMs using AI to shape the industry over, the next 10 years? From our perspective, we're using the data in many ways. We've actually used it through manufacturing capabilities, where we increased the output in one of our turbine blade facilities by looking at historical data, looking at machining operations, etc. We're investing in people through AI, making their roles, how shall I say it? I would like to say easier, but nothing's getting easier. But, that data's there to assist them when they're looking at doing whatever the task is. But one of the main things that we're using it for, and I think is important to you, is maximizing aircraft availability. That's what we're using AI for. And that's what's important to you guys, to your principals, etc. So we take all this data, not only the EHM data, but we take data from the shops, we take data from our stores, from manufacturing, from finance, from everywhere. And that allows us to, through AI, to predict what spare parts we want, what regions things move quicker in, what our engine shop capacities need to be, etc., etc. And we're actually developing ourselves, we used to call it, it's called the engine network, but we used to call it Facebook for engines, because that's basically what it is. And it can track everything on that one engine. So has it had shop visits, its performance data, spares, events in service, and that allows us then to have improved decision making, planning shop visits for you, planning your maintenance, that type of thing. So we're using it to help manage the fleet to ensure aircraft availability.
I think to answer the question of where we're going in the next 10 years, we kind of have to reflect a little bit back on the last 10 years and really over the last 2 years where AI has really sort of built up so much momentum. I mean, I think probably most people in this room have used ChatGPT at least once to do something for themselves or just to play around with it. And it's really amazing how much it's progressed from being something that you're using, I think, for a really discrete task, like maybe in business aviation, the use of it for things like spare parts inventory or management, to more complex tasks. And I think AI struggles right now, or things like ChatGPT struggle right now with really critical thinking tasks, but we're starting to see that shift. And I think at GE you could see that with our AI blade inspection technology, which is not on our Passport engines at this point. It's something that's been deployed for our NX engines, which power the 747s and 787s. But it's a really interesting technology that can, diagnose issues with turbine blades based on images. And I think that's something that we can share learnings with our other product lines in business aviation. I think that will happen across the industry. You'll see similar kind of things at Rolls-Royce or wherever it is. But I think the last couple of years really have given us so much momentum in AI, and we'll see so many new things pop up. Like I know we talked about autonomous vehicles earlier. I don't know that I'm personally ready to get on an eVTOL that doesn't have a pilot, or any aircraft for that matter, but I think certainly you'll see assist programs, which is the word that Mark used, I think, quite well. I think that kind of going forward, we'll see things more like self-diagnosing on engines and also self-treating. So you'll see an identify issued by AI, not just alerting that issue, but diagnosing it and also giving sort of a troubleshooting to the crew on how to repair that proactively so that, there's no big event.
I mean, yeah, you're quite right. I mean, that's what we were talking about, being able to do the two-way communication with the aircraft, to do the troubleshooting. And, people are brilliant. We've got some great experts, same as you have, understand, use turbine blades, understand turbine blades inside out. But that information, that knowledge and everything is theirs. And it's very subjective. Another guy may have another view. At least with AI, with it capturing everything across all engine types, yep, it can just pull everything together so very, very quickly and just make that task, you know, far easier to diagnose and so much quickly to get in there and do something. Which again, what does it do? Makes your aircraft available, doesn't it? Which is what you all want. So.
Excellent. Are there any maybe questions from the audience?
We've done our bit.
Great.
Thank you.
Brilliant. Thank you very much.
Thank you.